Read the problem carefully. Alice has a fresh cup of hot coffee that has a temperature of 180 degrees Fahrenheit. The temperature of the room is 70 degrees Fahrenheit. Let x equals number of minutes after Alice pours her coffee, and let y equals the temperature of the coffee in degree F. 5 minutes after Alice pours her coffee, its temperature is 160 degrees Fahrenheit. Write an equation to model this situation. How can we model this problem well? However, why shouldn't we solve this problem with linear or quadratic functions and instead use an exponential function? That's a great question. Trying to solve this problem with linear or quadratic functions might not provide an accurate representation of the situation. Here's why. Linear function. A linear function assumes that the change over time occurs at a constant rate, represented by a straight line graph. However, in reality, temperature doesn't decrease at a constant rate over time. Initially, it cools rapidly, but as time goes on, the rate of cooling slows down. Quadratic function. A quadratic function, represented by a parabolic graph, assumes rapid change initially followed by a decrease. This kind of function is suitable for scenarios like objects falling under a constant gravitational force but doesn't accurately model the temperature change of coffee. Therefore, to model this problem more accurately, we use an exponential function. Exponential functions capture the idea that the temperature decreases rapidly initially and then gradually levels off over time, which better reflects the behavior of cooling coffee. To model this situation using an exponential decay model, let's proceed with the following steps and solve it. Step 1. Use the exponential function. Y equals a times b to the power of x plus k. Step 2, we check the given conditions. Step 3, now, let's plug in the initial temperature of the coffee, x equals 0 and y equals 180, then, a, becomes 110. Step 4, substitute 110 for, a. Step 5, plug in the second temperature of the coffee, x equals 5 and y equals 160, then, b, becomes 0.96066. Step 6, complete the exponential decay model. Math the force be with you.